Hi everyone. So we were continuing the space missions probes, and in the list now we have the James Webb Telescope. Now the James Webb Telescope is basically the successor of the Hubble Telescope, successor of a Hubble Telescope, and it has to be launched in 2021. And it is 2.5 times bigger, 2.5 times of Hubble telescope, and actually 6 times more powerful, and it will orbit the sun. That's important because this is what makes it different from the Hubble, that it will orbit the sun. The next one in the list is the Artemis. Artemis is a joint mission of NASA plus ESA plus JAXA, that is a Japan, and Canadian Space Agency. Now its aim is to land the first female and the next man on the moon, specifically at the lunar South Pole region by 2024. Further, it will establish sustainable exploration by 2028, and the learnings from the mission will be used to send the astronauts to Mars. So this is its main aim, that is the first female, right, and next man where on the moon by 2024. So that is mainly about the Artemis. The next one in the list is basically the Lunar Orbital program, that is called the Gateway. So it is in development space station in the lunar orbit itself, intended to serve as a solar powered communication hub, basically a science laboratory or a habitation module, a holding area for the rovers. So that's why it is critical to human presence on moon. So it's more like a workshop on the moon, you can say. So it will play a major role when we will, when we have an Artemis in the program, when we have a female and the man basically on the moon, then this will play a huge role. So it is being developed by all the International Space Station, ESA, NASA, JAXA, Canadian, all of them together. So I would say that it is more like a space station in lunar orbit, which will be a science laboratory, habitation module, etc. The next one in the list is the COBE Satellite. Now the COBE Satellite is basically stands for the Cosmic Background Explorer. Cosmic Background Explorer, right? So it will explore the CBM, and that's it. And it was actually the first one to confirm the CBM radiation, CMB radiation, I mean, cosmic microwave background radiations. We will discuss about CMB in the upcoming lectures when we study about the physics behind that. Now the next one is the TERRA and AQUA. These are the NASA's Earth observation satellite. So NASA's Earth observation satellite. The AURA is basically the Earth observation satellite for stratosphere, ozone, and the aerosol in upper atmosphere. So it is Earth observation satellite for stratosphere, ozone, and aerosol in the upper atmosphere. So these are basically what we call different missions by the different organizations. Apart from that, there are a few other missions that we should know about in a very small manner, so that at least we know that they exist, like BEPI COLOMBO. Now the BEPI COLOMBO is basically the mission which was sent to the Mercury, and this is a program for the the ESA and the JAXA itself. So remember, it's a Mercury. Then there we have a JUICE. The JUICE is basically for the Jupiter the Jupiter Icy Moon Explorer. So it is Jupiter Icy Moon Explorer, and this is basically the European project ESA, and the first non-American outer solar system mission it is. Then we have a Copernicus. The Copernicus, the name itself says that it is a European based program, the European Earth Observation Program. This is basically, so it is European Earth Observation Program. So I've written EO, means Earth Observation Program. So the main objective is to monitor our planet and its ecosystem. It will have the constellation of the 6 families of the satellite, which is we call as a sentinels. So we have a 6, the families of satellite, and these are what we call as sentinels. Apart from that, the coordinated and managed by the European Commission. It will allow the full, free and open access to all data which has been collected in this one, and the scientists, policymakers, entrepreneurs can use it. Now it has a different themes: climate change, land monitoring, security, atmospheric monitoring, etc, etc, and you can easily answer them on the basis of the random guess, because applications are pretty much same in most of them. The next one in the list is the Rosetta. And one more thing important about the Copernicus program was that wait a second, India has joined the Copernicus program in 2018. So that's, I missed that India has joined in 2018 the Copernicus program. So according to the European Commission, it will provide India with the free, full, open access to the data from the Copernicus Sentinel families. That's it. So this is what it is, and in return, the India will also provide them a data through our satellites also. The OceanSat and etc, etc. So it's like a barter system. You provide me some, I'll provide you something else. Now the next one is the Rosetta. The Rosetta is basically to study the comet. Rosetta, it's an ESA mission. It is for the comet and the ESA. That's it. Only 2 words you need to remember. The cosmic visions are basically the ESA. It's basically a European campaign for space exploration, similar to the Discovery program. So I just write it here that it is similar to Discovery program, and it is ESA. So this is mainly the cosmic vision is, and Discovery program, or you can say the New Frontier programs, in which we are exploring our solar system and the exoplanets and everything. So it's connected to that. Apart from that, the next one is ATHENA. ATHENA is basically a telescope, advanced telescope for the high energy astrophysics. Shall I write it here? It is advanced telescope for high energy astrophysics. So the X-ray observatory has been planned. The observatory has been planned for 2031. So this is mainly about the ATHENA. Then we have an AIDA, that is basically the asteroid impact and deflection assessment, similar to the one that we have. We have earlier, the hammer was there, the dart was there. Similar to that, we have the AIDA. It's for asteroid, right? And yes, that's it. If you want to write me a full form, then it is asteroid impact and deflection assessment. Yes, so the space probe to test the impact model of whether a spacecraft could successfully deflect an asteroid on a collision course with the Earth. So this is what it does. Then the next one in the series, we have basically the change for Now the change 4 is basically the China's lunar probe. You must have heard about it in newspapers. It's China lunar probe mission. That is basically the first ever probe to land on the far side of the moon. Far side of moon. And this far side is basically what we call as a Von crater. Von Karman crater. That is basically the south pole region of the moon, which is the largest crater in our solar system. Let me write it here. It is in the south pole and largest in solar system. It's the largest crater in the solar system. So that is why. And U22 was actually the the name of the rover which was under this change 4. There is no space left. So U2, YUTU, U22. So U22 was basically the rover. So don't get confused, huh? It's getting hodgepodge. Then the next one in the series is the HAYABUSA mission. So the HAYABUSA mission is a Japanese, mark these words, it's not a Chinese, it's a Japanese space exploration mission. And it will study the asteroid, that's important. It will study asteroid. So it will study the asteroid. And Hayabusa 1 was sent in 2003 to study the feature of the asteroid Itokawa. Now the Hayabusa 2 mission was sent in 2014. So so there were actually 2014 mission was sent, and it studied the asteroid. Asteroid was name of it is Ryugu, Ryugu. So you can remember this name. The latest one is Ryugu. It was sent in 2014. Now the next one is the BIRDS project. Now the BIRDS project was recently announced. It was in the news that the Japan's project. It was again the Japan was there. Japan's project basically to support the non-space-faring countries to build their first satellite. For all those countries which are not capable of making their own satellites, so Japan will help them in order to make their own satellites. So basically more like a soft power here, that to support non-space-faring countries to build their first satellite. So this is what it mainly about. Now in this, it is called the Joint Global Multinational Bird Satellite Project. That is a full form for that. You can easily Google it down. And in this, there are actually two of them. The first one is basically the BIRDS 1, and second is basically the BIRDS 2. These are the two groups. In the BIRDS 1, basically there are 5 countries, which are Ghana, Mongolia, Nigeria, Bangladesh. I think yeah. So basically the Ghana, it's Mongolia, Nigeria, Bangladesh, and the 5th one was, I am not getting it right now. Maybe you can Google it down because I don't remember it. So in the third bird was basically, it was actually the neighbor of India. The Bhutan was there, the Philippines, and Malaysia. So this was basically about. Now next was basically the SPICA. So let me demarcate it here so that you won't get confused. The SPICA is basically the effort of the Japan and the ESA. So it is basically a telescope, that is basically the infrared telescope for the cosmology. Basically, it aims to elucidate the process that enriched the universe with the metal and the dust and led to the formation of the habitable world by observing the metal and dust enrichment through galaxy evolution. So that's why we said that it is basically infrared telescope, which will study metal and dust. And with help of this, we will able to describe the evolution of the universe, galaxy, how they evolved themselves to the habitable system. This is what it is. Now the next one in the list is a space debris project. So the space debris is something that we have so many satellites in space and we don't bring them back, and sometimes they not functioning or they break down and they keep on rotating around, revolving around the earth, and this creates huge amount of debris. And sometimes what happens then, there are certain asteroids which break them, or the same parts break other satellites, and because of that, the number of debris multiply each and every time whenever there is a hit on those satellite. So this is basically creates more debris in the space. So to remove this thing, there are multiple projects came into the picture. The first one was basically the remove debris project. So it was remove debris project. Now this project actually aims to clean the space debris using CubeSats. Now the CubeSats are basically the small satellites. So I'll just write it here that via, or I can say a remove via CubeSats. Now these are basically the microsatellites, or small satellite, not micro, small satellites. Okay, small satellites. This is what it means. And this is not stat, this is sat. Cube sat. Yes. The second one is the clear space. The clear space 1. Now the clear space 1 will be the first space mission to remove the items of the debris from the orbit. It is planned to be launched in 2025, and it was led by the Swiss startup. So this is basically a Swiss startup and launched in 2025. That's it. And the third one that you need to know is about the Kessler Syndrome. The Kessler Syndrome, as I have discussed right now, that once past a certain critical mass, the total amount of the space debris will keep on increasing. The collisions give rise to more debris and lead to the more collision, that is creating a chain reaction, that more and more debris is created whenever the collision happens. That's a Kessler Syndrome. The fourth one is basically the astrospace. Astrospace is basically Japanese company which is researching for the debris removal. So you can just, it is Japanese company. And also there is one more of it, I'll write it here, that is basically called the MEV-1. MEV basically the mission extension vehicle. It is actually made by the US companies, by USA, in order to remove the debris. So this is pretty much about some of the major projects and some of the telescopes and the satellites which have been sent, and this is mainly about these things. In the next lecture we will read more about the telescopes. There are few important telescopes like giant meter wave and radio telescope, so we'll discuss them in the next lecture. Thank you guys.